Hi, in this video I'm gonna show you a half-wave rectifier circuit in a more practical terms, and how to set up a half-wave rectifier circuit, how it works, what are the advantages and limitations of half-wave rectifier circuit. This is the first video on our series of rectification circuit. In the next video we're gonna learn also about center tap rectifier circuit and the full bridge rectifier circuit. So let's start with the half-wave rectifier circuit. A half-wave rectifier is a type of rectifier that only allows one half cycle of an AC voltage wave form to pass through while blocking the other half using a single diode. You can think of diode as a water valve, or in this case as an electric valve that only allows the current to pass in one direction and blocking the current from flowing in the opposite direction. So the transformer produces an alternating current by stepping down the high voltage AC from 240 volts to the lower desirable voltage depending on the appliance you are going to use. But the voltage stepped down is still alternating current. So to convert the current into DC voltage, we are going to use a single diode to form a half-wave rectifier to deliver the power to the load, or in this case to this DC motor here. So here I've tried to connect this brushless DC motor directly to the transformer, and the one that I've already connected it directly to the battery, and you can see the difference here. The motor that is connected to the transformer does not rotate, while the one that is connected to the battery, it rotates. And the reason here is that the transformer produces an alternating current, while the motor only works on DC current. So when the current from transformer passes through the motor, it makes it move back and forth very rapidly in such a way that the motor stay stationary, and it has no chance of either rotating forward or backward, but the current is still passing through it. And if you let it stay on connected to the transformer for a long period of time, it will heat up the coil and it will end up destroying this motor. There are other motors that are being designed to work on AC voltage, but not every motor can work on AC voltage. So that's why we have to make a rectifier circuit. So you can think of AC voltage as a battery terminals whose polarity changes frequently. So if this terminal is positive on this second, in the next fraction of second it's negative, and then it changes to positive again very rapidly, and this happens many times per second. And if you try to draw a AC curve, you get a curve that looks like this. What the diode does is to block the other half wave of AC voltage and allowing the other half to pass through, and this will result into the curve that looks like this one here. So this is a half-wave rectifier waveform that we get from a single diode. But this DC current is still pulsating, meaning we don't get a smooth DC power as the one that we get from the battery. And to achieve that, a capacitor is added in parallel to the load to help to smooth out that pulsating voltage. So the capacitor will store some energy when the voltage reaches the peak of the curve, and as the voltage drops to the zero, the capacitor will deliver that energy to the load a little bit until again the AC voltage rises to the top of the curve, resulting into a more smooth DC power. So following our circuit diagram, our half-wave rectifier circuit diagram, we are going to connect this electrical component together to make a half-wave rectifier circuit. Then we are going to connect this load or this DC fan to the circuit to see if it can rotate this time around. So let's connect the electrical components together. So as you can see here, we have already wired everything together. The diode is wired in series to the load. Let's complete the circuit. You can see here the motor is now rotating. The diode was wired in series to the load and the transformer, and now the motor is rotating. Then following the circuit diagram, there is one thing that is missing. This is a capacitor. The capacitor is supposed to be connected in parallel to the load. So let's connect the capacitor in parallel to the load. This will act as our filter and check the difference between when the capacitor is connected and when capacitor is not connected to the load. So now we have already seen the difference between when the capacitor is connected in parallel to the load and when the capacitor is not connected in parallel to the load. So whenever you design the circuit, don't forget to put a capacitor in parallel to the load, as this will make a huge difference because it helps to smooth out that pulsating voltage and it helps to have much more smooth DC output current. So don't forget to add a capacitor in parallel. So we have already seen a half-wave rectifier circuit. It is simple and quite easy, but there are limitations to this circuit configuration. And the limitation is that they produce low output voltage. As you can see it here, the transformer produces an output voltage of around 20 volts. This transformer produces output of around 20 volts. But on the multimeter, we see half-wave rectifier, meaning that with one diode, we only get 9 volts, which is only more than half of the voltage that was originally produced by the transformer, which was 20 volts. So we don't consume all the power that is produced from the transformer, and more than half of the power is get wasted because our rectifier circuit produces around 9 to 10 volts, while the transformer produces around 20 volts. And this is because during the first half cycle of the AC voltage, the current is allowed to pass, but on the other half, the current is not allowed to pass. And the one that is being blocked is the one that is get lost. That's why you can see here the difference. Well, despite the limitation of half-wave rectifier, but also they have got some applications. For example, they are used in signal demodulation and for signal peak applications of electromagnetic waves. So also they are very cheap and quite easy, very easy to construct. As you have seen here, we have just used one diode. In the next video, we're gonna learn about center tap rectifier, where we are going to use 2 diodes. So I'll put a link in the description for that video. Don't forget to subscribe and see you next time.